This question is from the chemistry of chapter Chemical Kinetics. In the question, the following data were obtained during the first order thermal decomposition of SO2Cl2 at the constant volume. Here is the relation given. We have two experiments given 1 and 2. When the time was 0 second, that time total pressure is 0.5, and when the time is 100 second, total pressure is 0.6. We need to find the rate of reaction when the total pressure is 0.5 atm. So in this question, we need to find the rate of the reaction. So rate formula is K into pressure of SO2Cl2. So based on this relation, we need to find the rate. But in the question, this rate constant is not given, and this pressure of the reactant is also not given. This is the total pressure. Total pressure and the pressure of the reactant is different. This total means the complete reaction, what is the pressure, and this is only for the reactant SO2Cl2. So let's start to solve this problem. So here, as you see, here is the reaction already given. So based on that, we can use our experimental table. So in the table, it is given that initially, when the reaction just started, that time is equal to 0. And the total pressure was 0.5 atm. Now, when the reaction just started, during that time, total pressure is equal to P naught, and the product has no pressure. So if we have to add all the pressure of the reactant and product, it's equal to, if we add all of it, it's equal to P naught. So we can say that this total pressure is actually equal to the P naught, and its value is 0.5 atm. Suppose similarly, if we have to find the relation of the reactant concentration with the total pressure, we can assume that suppose when the time is equal to T and we don't know pressure, so we just write it as Pt. So it's equal to P naught minus P dash. This is the change in the pressure of the reactant, and this is the new pressure of the product. So what is the total pressure in this case? If we add, it will be equal to P naught plus P dash. So this is the general relation if we have to find any pressure. So total pressure is equal to P naught plus P dash. And always whenever you have to use the relation of the rate constant, we always take the relation of P naught minus P dash. So now in the second experiment, it is given that when the time is 100 second, then the total pressure is 0.6 atm. So let's substitute the value that we got it here. At T is equal to 100 second, total pressure is equal to 0.6 atm. So now if we put the value here, 0.6 atm is equal to P naught is 0.5 plus P dash. So P dash is equal to 0.1 atm. So we got the value of P dash, but we have to find the value of P. So P is equal to P naught minus P dash. P naught is 0.5 and P dash is 0.1. So P is equal to 0.4 atm. So we found the pressure of the reactant at time is equal to 100 second. Similarly, we have to find the pressure of the SO2Cl2 when the total pressure is 0.5 atm. So similarly, we can write it here when the total pressure is equal to 0.65 atm, then Pt is equal to P naught plus P double dash, and P double dash is equal to 0.65 minus 0.5, so it's equal to 0.15 atm. So we got the decrease in the pressure. So here if we have to find the P value, this P value for this total concentration, so it is equal to P naught minus P double dash. So 0.5 minus 0.15 is equal to 0.35 atm. So we have found the P value. Now we have to find the value of K. K is equal to, this is a first order reaction, so 2.303 divided by time log P naught by P. So K is equal to 2.303, time is 100 seconds, log P naught is 0.5, and this P is equal to this value we can take as 0.5, because that time we know 100 seconds, so we substituted 100, 0.4. So K is equal to 2.303 divided by 100 into log 1.25. So K will be equal to 0.0022 second inverse. Now we have the K value. Now we have the pressure value. So if we have to find the rate of the reaction, so rate of the reaction is equal to K into P of SO2Cl2. So K is 0.0022 and the pressure is 0.35. So rate is equal to 0.0077 mole per liter second. So this is the answer of this question.